Thank you for calling SpeedNet, your trusted high-speed internet service provider. Please be aware that your call may be recorded for quality assurance and training purposes. For billing and payments, press 1. For new service or product inquiries, press 2. For technical support, press 3. To move your... If you're experiencing no connection or internet downtime, press 1. For issues with slow internet, we're sorry to hear you're experiencing connectivity issues. Please check if your modem and router are properly plugged in and powered on before proceeding. If you've already done this and still need assistance, please stay on the line, and a technical support specialist will be with you shortly.
2,000 years later.
Good evening. How can I assist you in your connectivity issue tonight?
Hello, I am a customer with SpeedNet. My internet quit working 30 minutes ago.
Have you tried turning your router off and on?
Hey, this is James. Welcome to my channel. Ever found yourself wrestling with your home internet and just couldn't get it to work? No sweat. This video is all set to walk you through some super handy network troubleshooting tips. Before you even think about dialing up tech support, I'll help you pinpoint what's going wrong with your connection. And even if we don't fix it right here, you'll be fully equipped to explain the situation to the tech wizards, speeding up the fix and getting you back online in no time. Stick around as we dive into the ins and outs of home network troubleshooting, making tech troubles a thing of the past. Alright, let's kick things off with some basic network know-how. Ever wondered exactly what the internet is? You've probably heard the term tossed around a lot, but have you ever stopped to think about how it lets you surf the web, stream movies, watch videos, and play games? Curious? Well, you're in for a treat because we're about to break it down. Easy peasy. Most of you out there, just like me, must have sent a letter before. Let's walk through what sending a letter looks like, shall we? First up, you write your letter and pop it into an envelope, sticking a stamp on it. Then you either drop it off at the post office or into a mailbox. Once the postal worker collects all the mail, it's off to the local post office for sorting. They divide up the mail based on where it's headed. Nearby destinations get handed off to postal trucks, while far-off spots mean the mail hops on a plane to reach another post office. After landing, the destination post office takes over, unpacking and sorting everything. Local delivery folks then grab the mail destined for their area, and voila, it arrives at its final stop. The recipient, thrilled to bits, tears open the package and revels in the joy of a friend's letter. Feeling grateful, they pen a response and send it back the same way it came. Just like when you hand your letter over to the postal worker until it's delivered to the recipient, you have no control over what happens in between. In the world of networking, this stretch is known as the backbone network. The backbone is dotted with various nodes. Think corporate networks, individual user connections, and cloud services, all of which are endpoints of this backbone network. Collectively, we refer to this as the Wide Area Network, or WAN. We'll delve deeper into their roles in future videos. Since we can't control everything happening on the WAN, our focus today is on a smaller scale, the home network, also known as the Local Area Network, or LAN. Corporate internal communications also use LANs, but let's not get ahead of ourselves. Going back to our letter sending analogy, we know that a destination address is essential for the postal worker to deliver our mail, and the sender's address lets our friend reply. The same rules apply in the digital realm, just in a different form. In networking, we call these digital parcels data packets. The sender's address becomes the source IP address, and the recipient's address is the destination IP address. The process of preparing our information for sending is known as encapsulation. Data packets follow a set of network protocols, similar to the sorting process in our postal example, to find a delivery path. They navigate through various points along the way, ensuring the packets ultimately reach their destination. All right, now that we're zeroing in on home networks, where do we start? Believe it or not, our homes are filled with networking devices. Take your laptop, for example. Yep, you heard right. Your laptop is a networking device. It might not have fancy network forwarding capabilities, but it does have the basic attributes of a network device, like the ability to package data packets we talked about earlier. And of course, you've probably already guessed that many other gadgets we use daily fall into this category. Your desktop computer, gaming consoles like the PS5 or Nintendo Switch, and your iPhone, to name a few. Then there are the more obvious pieces of home network equipment: switches, routers, firewalls, and wireless access points. Now I can hear some of you asking, wait a minute, when did my house get all this tech? The simple answer is that in most home networks, the router you're using likely combines all these functions into one device. It has the basic capabilities of these separate network devices, whereas in a corporate network, each device has its specific role and more advanced features in its domain. Let's dive into these devices, starting with a desktop computer as an example. Typically, it has two ways to connect to the network. 1. A wired network card, also known as a NIC, where you plug in your Ethernet cable, and 2. A wireless NIC, which might be integrated into the motherboard so you won't see it directly. These NICs use their assigned IP addresses to package data packets. Now, let's get troubleshooting, starting from the ground up. First, check if your network NIC drivers are up to date. Open the Device Manager, right-click on your network card properties, and select to update your network card driver. If you don't find a newer version or are told it's already up to date, head over to the manufacturer's website of your network card. Compare the version there with yours. If it's not the latest, download and update it. You can use your phone's hotspot for an internet connection if needed. If a hotspot isn't available, or you're worried about data usage, or if the network is completely down, we can skip this step. For wired connections, check if the port lights are blinking. If there's no activity but you're sure the cable is plugged in, then check your Ethernet cable. If you have a spare that you know works, try swapping it out. Next, let's see if your wired and wireless network adapters are enabled. In some rare cases, they might have turned off, and we'll need to turn them back on. For Windows 11, click the Windows button and search for Manage Network Adapter Settings to check if your adapters are enabled. For Windows 10, you can search for Change Adapter Settings. The display method might vary across different operating systems, but I'm confident you'll figure it out. After checking the above, let's look at your IP address. Press the Windows key, search for Command Prompt, and enter ipconfig/all. Check if your IPv4 address is listed. If it's missing, it's likely your router hasn't assigned an IP address to your computer, which we'll cover shortly. For those who might have set a static address, go to the properties of the respective adapter and open the IPv4 properties. If it's set to obtain an IP address automatically, you can skip this step. If there's an address listed, you'll need to log into your router to check the DHCP range, gateway, and DNS addresses. This step is rare but necessary for some, especially if your router and addresses were manually configured by someone else, and the router has since been reset to factory settings, changing these values and potentially disrupting normal data packaging and sending. Another rare possibility is an IP address conflict. Windows typically notifies you of IP conflicts. In other situations, you don't receive an alert, but experience intermittent connectivity. It could also suggest another device on your network is using the same IP address. Specifically, in Windows 11, if you've assigned a static IP and notice duplicate beside your IPv4 address after executing ipconfig/all in command prompt, this confirms an IP conflict. To resolve this, you can either modify the conflicting IP address on one of the devices or opt for DHCP, which dynamically allocates IP addresses, thereby preventing such conflicts. If you've gone through all the previous steps and still aren't satisfied with the results, it might be time to focus on the last device in the chain, your home router. In addition to being a multifunctional device, as mentioned earlier, the router also consists of various physical components, including RAM and a CPU. Essentially, the router operates on a series of codes, and poorly written code can lead to memory leaks. Over time, these leaks can prevent memory from being properly released. Once the memory usage hits 100%, the router will no longer have the resources to assist in forwarding data packets. To avoid this issue, it's recommended to check the manufacturer's website for the latest firmware updates and upgrade your router's firmware. Another issue that could affect your router's performance is inadequate ventilation, which can lead to the CPU overheating. Regardless of the router's design, they typically have ventilation ports that might get blocked by dust. If your router is collecting dust, it might be time to clean it out. Additionally, ensure that your router is placed in an area with good airflow and kept within an optimal temperature range between 32 degrees Fahrenheit and 104 degrees Fahrenheit, 0 degrees Celsius and 40 degrees Celsius. Going beyond these temperature limits could potentially lead to router malfunctions. Beyond the points discussed, your router connects to your service provider in specific ways. To forward data packets, the router needs to acquire a public IP address, while most of our home networks use private IP addresses. Without conversion, these packets cannot travel across the main internet backbone. Most service providers use a protocol called DHCP to dynamically assign these public IP addresses. You can check if your router has received a public IP address by accessing the router's built-in web page through your browser and navigating to the connection section. For home networks, any address outside the range of 192.168.0.0 to 192.168.255.255, which are private addresses, is generally considered a public IP address. There are also other ranges of private IP addresses, which are less commonly used in home networks and more so in corporate settings. These ranges are also available online for reference. If you confirm that you have a public IP address, you can use the tracert command to test connectivity to the destination 8.8.8.8. If you cannot reach the destination, it's time to contact your service provider for assistance. If you don't see a public IP address, then there are further steps to consider. Next, let's examine the cable connecting your router to the service provider. First, ensure it's correctly plugged in. Generally, there are two types of connections, coaxial and fiber optic. Coaxial cables require your router to have a modem function or to be connected to a separate modem to convert the signal. These cables rarely have issues unless physically damaged. Fiber optic cables, offering significantly higher bandwidth, are more sensitive. If you've ever had to move your router and unplug the fiber optic cable, dust could settle on the connector, severely impacting its function. Unfortunately, most users don't have the proper tools for cleaning these connectors, and attempting to do so with your hands can damage the fragile fibers and further contaminate them with oils from your skin. If you've tried all the suggested steps and the issue persists, professional help is needed for inspection and cleaning. For devices connected via Wi-Fi experiencing intermittent issues, checking your router's Wi-Fi settings could help. Some manufacturers combine the 2.4 GHz and 5 GHz bands under a single network name. If that's the case, try separating them into distinct networks, naming them with _2G and _5G suffixes. Older network cards may struggle with combined signals, and splitting them allows you to choose the most stable connection for your device. The 5 GHz band offers faster speeds but will not appear in the Wi-Fi list of devices that do not support it. Lastly, Regarding the DHCP protocol mentioned earlier, most devices rely on DHCP to obtain an IP address, which typically works without issues for home networks. However, in scenarios where static IPs are used and the router is reset to factory settings, the preset DHCP range and gateway might not match the manually set IP on your device, preventing it from connecting to the router and consequently the internet. Thanks for watching. If you gained value from today's video, please hit the like button and subscribe for more insights. Got questions or suggestions? Leave a comment below. Your feedback helps shape our content. Don't forget to turn on notifications to never miss an update. Happy networking and see you in the next video.